Hello students, welcome to my channel. In the last video, I have solved all the sums of exercise 3.1. I hope all of you understood the sums which I have done in the last video. So today we are going to start a new part of new things, new terms for logarithm. That means after this video or after this explanation, we will start exercise 3.2. So now please go to page number 83. Page number 83, 3.2, computation with logarithm. That means till page number 82, actually we have done all the sums related to logarithm without the values. Suppose log 70, we have not got that type of numbers. When we get log 70, then we are getting difficulties to find out the value of logarithm. So log 10 is 1, we know. Log 100 is 2, we know. Log 1 is 0, we know. Log a by b is log a minus b. Log a into b, log a plus log b. Those formula we got. But some of the values of logarithm we have not got till now. So now we will learn how to find out the value of some special logarithm. So for example, log 75. So how to find out the value of log 75, log 85, log 1500. So those things, those numbers we are going to compute, we are going to count, we are going to learn how to find out logarithm of some special number. So computation with logarithm. Computation with logarithm. In our earlier discussion, we mentioned about two types of logarithms depending on their basis. These are common logarithm and natural logarithm. It is to be noted that the logarithm of a number depends on its base. For example, log 16 base 2 is equal to 4. Log 16 base 2 equals to 4. And log 16 base 4 equals to 2. Here there is 16, here also there is 16. But base is different. So depending on base, we will get the value also different. Log 16, here also log 16. Here base is 2, here base is 4. Here value is 4, here value is 2. So two different value because the base is different. So depending on base, we will get always different values. So how do we get log 16 base 2 4? Log base 2. So 16 we can write 2 to the power 4. So 4 will come here. You know that. So log 2 base 2 is 1. So that means 4. Okay. Or you can think this way also. 2 to the power 4 is equal to 16. This we know already. We have got in a previous video and previous part of this logarithm. So this is a formula. As this one, log x to the base a equals to n, or a to the power n equals to x. This is a formula. A to the power n is equal to x. So same thing here. 2 to the power 4 is equal to 16. It is correct. Same thing here, 4 square is equal to 16. 4 square is equal to 16. So, this is the base. This is the base. But answer is same, result is same. But base are different. So, anyway, here log 16 is 4, here log 16 is 2. Here base is 2, here base is 4. So, that is what here written. So, I am trying to make you understand what is written in the book. What is written in the book? You have to understand what is written in the book. So the logarithm of 16 differs with its base. Logarithm of 16 differs with its base. As different bases, so values will be different. Again, the logarithm of different numbers are different even if the base remain the same. For example, here base different. Here what we have got? Base different. But logarithm is same. Log is same. Here log 16, here also log 16. Now, second, so the logarithm of 16, again, the logarithm of different numbers are different if the base remain same. Now base same, log 100 and log 1000. Here base is 10, here also base is 10. Base same now. But here value will be different. Log 100 base 10 will be 2. Okay. Log 1000 base 10 will be 3. How? 10 square is equal to 100. 10 cube is equal to 1000. That we know. That is a formula. 10 square is equal to 100 and 10 cube is equal to 1000. So here base same. Here base different. Here base same. Okay, I hope you understand. You have understood this one clearly. I hope that this one also you have understood clearly. What is written here, just I have explained here from my side. So that you can, this one you can get one more example. Log base 2 here. Here also log base 2. Here I have written 16. Here I have written suppose 64. So here the value will be different. Log 16 base 2, log 64 base 2 will be different. 2 to the power 4 is 16. So here we will get 4. 2 to the power 4 is 16. 2 to the power 6 is 64. 2 to the power 6 is 64. So base is same, but logarithm is different. So we will get different value. So whether base different or when base different, logarithm same. When base same, logarithm different, but we will get different value. That is what here it is written. In this lesson, we will discuss the method of calculating using logarithm having base 10. So if in case there is no mention about the base, that it is to be assumed that the base is 10. So in this chapter, what we are going to learn now, so base will be empty. So suppose it is written like this, log 50. Here there is no base, that means there is 10. Base is 10. That is what written, to be assumed that the base is 10. So base is empty means we will assume, we will think, we will take it as 10. Base is empty means base is 10. Okay. Determination of logarithm of a number. We know that log 10 base 10 equals to 1 and log 100 base 10 equals to 2. Now what will be the logarithm of a number to the base 10 when the number lies between 10 and 100? Look here. Log 10 base 10 equals to 1 and log 100 base 10 equals to 2, because 10 to the power 1 is 10, 10 to the power 2 is 100. Okay, so logarithm of a number to the base 10 when the number lies between 10 and 100. Between 10 and 100, here 10 is there, here 100 is there. So between 10 and 100, we will get a number. Whatever number that will be greater than 10 and less than 100. Like it is this one, this one I have written, you will understand now. Let us take log of all side, log x, log 100. Log 10, 10x, 100. Everywhere log is taken. Everywhere log is taken. So log 10, log x, log 100. Log 10 is 1. Log x. Log 100 is 2. So log x will be greater than 1 and smaller than 2. That means the value of log x, whatever it is, that will be between 1 and 2. Between 1 and 2. Between 1 and 2. That means not 1 and not 2. Neither 1 nor 2. Neither 1 nor 2. Suppose 1.5. Suppose 1.26, 25. Like that. 1.57. So this way. So this way you will get a number between 1 and 2. So log x will be, here that is what written, log x will be this one. This one it is written here, log x base 10 is greater than 1, smaller than 2. So what will be the value of log x? Log x is equal to, what is written here? Log x is greater than 1. Suppose I am saying, suppose 1.7. Suppose the value of log x is 1.7. So how can we write 1.7? 1 plus 0.7. 1.7 or 1 plus 0.7 is same thing. Okay, then what will that log x equals to 1 plus 0.7. That means we will get a number here. After that we will get a decimal number. After 1 and before 2, we will, whatever number we will get, all will have decimal part. Between 1 and 2, you can assume any number. Just for example, 1.75234. 1.75234. This will be between 1 and 2. This is between 1 and 2. This number is between 1 and 2. So that means what? 1, you will get surely 1. Then plus other decimal part. So I have assumed here 1.7. Suppose log x, the value of log x is 1.7. So we can write log x equals to 1 plus 0.7. So log x base 10 equals to 1 plus a positive fraction. 1 plus a positive, decimal number means fraction. So this will be always positive. Remember, always positive. So log x base 10, or base is not there, it is no problem. But log x equals to whatever we get, first this number you will get 1, because log x is greater than 1. As I have assumed 1.7. So second term will be always fraction or decimal. 0.7 means what? 7 by 10. Fraction or decimal, same meaning. 0.7 means 7 by 10. So what is written here? This is a very important line. Log x base 10 equals to 1 plus a positive fraction. This is a formula. Log x is equal to 1 plus a positive fraction or decimal number. 1 plus a positive fraction. So log x equals to, always you will get like this. If it is between 1 and 2, if it is between 2 and 3, then you will get 2 plus something. If the value is between 2 and 3, then we will get 2 plus a fraction. Fraction means decimal number. Suppose between log x is between 2 and 3, then we will get 2.82. Suppose I am saying. Or we can write 2 plus 0.82. So this will be 2 between 2 and 3. So 2 plus more than 2. Log x will be more than 2. So 2 plus something. What is that something? That is always a positive fraction. That is always a positive fraction. This is what here it is written. So I hope you understand the value of log x. Anything we have to write, we may get, but first one will be an integer. That will be an integer. And second term will be always a positive fraction. Positive fraction means a decimal number. Here we take another example. Log 1000 base 10 equals to 3. And log 10,000 base 10 equals to 4. So whatever it is given in the book, that is what I am explaining. So that you don't get any confusion. So here how it is correct, how it is true, because 10 cube is 1000, 10 to the power 4 is 10,000. 10,000. 10 to the power, here something it is written here, it should be 10, one more 0, okay. So that the logarithm of 1000 is 3 and logarithm of 1000 is 4. Sorry, 10,000 is 4. From this we understand log of, look here, log 1000 and here log 10,000. Between 1000 and 10,000 you can take any number. Here they have taken 4315. 4315. 4315 is between 1000 and 10,000. Log of 4315 will be between 3 and 4. Log 1000 is 3. Log 10,000 is 4. So log 4315 the whatever value we will get, that will be between 3 and 4. That means that we will get 3 plus any positive fraction or decimal number, any. Like here 1 plus, because 1 and 2, between 1 and 2, if it is between 2 and 3, 2 plus. The value of 1000 is 3. Value of 2000 will be 3 plus something. 3 plus something. What is that something? That is a positive fraction. A positive fraction. Why 3 plus? Because it is greater than 3. Log 1000 is 10. Sorry, log 1000 is 3. Log 2000 will be 3 plus something. Okay. Suppose log 2000 is 3.2. So how can we write this one? 3 plus 0.2. 0.2 we can write 2 by 10. That's fraction, no? Positive fraction. So 3 will be surely there. Surely there will be 3. Because whatever value we will get, that will be greater than 3. Log 4315 will be greater than 3 and less than 4. Less than 4. 3.9999 maybe. Whatever it is. But it will not be 4. It will not be 3. Whatever value, that will be more than 3. Greater than 3. So log 4315 base 10 is a whole number. That will be a whole number plus a pure decimal number. A positive fraction or a pure decimal number, same meaning. As I have shown you here, 0.2 means it is a purely decimal number because it is positive. So that can be written as positive fraction. 0.2 we can write as a fraction. So no need to worry about that word. So you will get a positive, a pure decimal. A pure decimal number means positive decimal number. Pure decimal number. One more example I will show you. This one, please pause the video. I can note it down. I will show you one more example. Log 100 base 10 log 1000 base 10. Log 100 base 10 is 2 and log 1000 base 10 is 3. So between 100 and 1000 you can think any number. Suppose I am writing log 435. Suppose. So log 435 will be 2 plus some decimal number. Because that log 45 is between 100 and 1000. So log 435 will be greater than 2 and smaller than 3. Suppose I am saying the value is 2.795. Suppose I am saying the value of log 435 will be suppose 2.795. So how will that? 2 plus 795. So it is a purely decimal number. A pure decimal number. And a whole number. This is a whole number means integer. You may get here negative number, no problem. You may get here a negative number. I hope you understand this. And here we are concerned about the base 10. We don't have to think any other base. Only base 10. So you will get next time base blank. That means 10. Now let us observe the following results. 10 to the power 0 equals to 1. It gives log 1 base 10 equals to 0. Why 10 to the power 0 equals to 1? Because look here. Log 1 base 10 equals to 0. 10 to the power 0 is equals to 1. 10 to the power 0 equals to 1. I have written here. So that is what here is. Log 1 base 10 equals to 0 or log 1 equals to 0. Here log 10 base written, here base is not written. Or you can write directly log 1 equals to 0. No need to write base because base we will assume as 10 only. Blank base means base 10. Log 1 equals to 0. Log 10 equals to 1. We don't have to write the base because it is assumed as base 10. So log 10 to the power 1. So this one you will understand now. Log 10 is 10 square is equal to 100. And this one already I explained. So this one already I explained how we are getting. Now these are all positive. Okay. These are all positive. Look here. This one I am writing 10 square is equal to 100. or we can write log 100 base 10 equals to 2. This is positive. Okay, now this side you see. Okay, log, here you see log 10 square equals to 100. 10 square equals to 100, but 10 to the power minus 2 is not 100. 10 square is 100, but 10 to the power minus 2 is not 100. 10 to the power minus 2 is 1 by 100. How? As we got in lower classes, a to the power minus m. How can we write 1 by a to the power m? Indices formula. So 10 to the power minus 2, we can write 1 by 10 to the power 2 or 10 square. So that is why it is 1 by 100. Here 10 square is 100, 10 to the power minus 2 is 1 by 100. I hope you understand this one. So 100. 10 to the power minus 2 is 1 by 100. Or 1 by 100 we can write 0.01. That you know, 1 by 100 we can make it decimal. So what we have got now? 10 to the power minus 2 equal to 0.01. I hope you understand this one. 1 by, suppose 4 by 42 by 100. How can we make it decimal? 0.42. After decimal 2 digits, because 2 zeros are there. Here only 1 was there. One single number was there, so 0.01. That you know, that I don't have to explain again. How to convert fraction into decimal, that you know already. So anyway, 10 to the power 2 is equal to 100. Here 10 to the power minus 2 is equal to 0.01. So 10 to the power 2 equals to 100. How can we write this one? This one will go this way, no? This way. 100 base 10. So here this base, this log 0.01 base 10. This one equals to minus 2. This is what here. Log 0.01 base 10 equals to minus 2. Or we can write log 0.01 equals to minus 2. Base no need to write. Base is empty, means 10 is the base. I hope this one you have understood. I will show you one more example. 10 to the power minus 3 is equal to 10 to the power minus 2 is 1 by 100. So 10 to the power minus 3 will be 1 by 1000. Or we can write 0.001 after decimal 3 digit, because 3 zeros are there. So how can we write this one? 10 to the power minus 3 equals to 0.001. 0.001. So how can we write in log now? Log 0.001 base 10, no need to write, equals to minus 3. This one, no? That you got already. So log 0.001. Log 0.001 is equal to minus 3. I hope you understand this. This one surely you have understood. And this one also I hope you understand. This is minus 3, okay? Minus 3. Minus 2, minus 3. So when do we get minus 2? When we get decimal log. Log decimal, we will get negative. Log decimal 01, 002, like this we will get a decimal number, negative number. So this is what here explained, this is what here shown. So just I have explained whatever it is written here. Okay. From these results we understand that if n is an integer, then the logarithm of 10 to the power n is an integer. So if these things you don't have to read so many things. So anything log of anything means a. In anything a comes first, letter a comes first, so log a. Log a is equal to 1 integer you will get always. You will get 1 integer plus a fractional decimal number. A fractional decimal number you will get always. First one you will get an integer, and second one you will get a fractional decimal number. Like previous, I have told you log x equals to 1 integer and other one is a fraction. Suppose 2.795. How I have written? 2 plus 0.795. This is a decimal, pure decimal number, and this will be a whole number, means an integer. An integer. Whole number or integer, same thing. So this is called, this number is called characteristic of the logarithm. Characteristic of the logarithm. And this part of the logarithm is called mantissa. Mantissa. This is what here it is written. This is mantissa and this is characteristic. The integral part is called the characteristic. Integral part. Without decimal, a number you will get, that will be called characteristics, and the fractional part, that means decimal part, will be called mantissa. The students should note that a positive real number a can be expressed as a factor of integral power of 10. This is not needed. So here the students the students should note a positive number a can be, so a equals to m into 10 to the power 9. What is written here? A is equal to m into 10 to the power n. Always you will get this type of number. How? I will show you one thing. Suppose 50. 50 we can write 5 into 10 to the power 1. 500 we can write 5 into 10 to the power 2. 5000 we can write 5 into 10 to the power 3. So this is what, this is m, this one. So both sides, suppose taking log. Log a, both sides I am taking log. Log m into 10 to the power n. Just taking log, nothing is done. Log a is equal to log m plus log 10 to the power n. Because multiplication we have to add in log. This is what here it is written. This is what it is here shown. Okay. So log a equals to n plus log m. Look here. One more line I will write here. Log a is equal to log m. Here power comes back. You know that. And log 10. Log 10 is 1. Log 10 is 1. You know that. So log a equals to log m plus n. So main what we have to get, what we have got now, log a is equal to n. Let us write first. N plus log m. So log a is equal to log m, n plus log n. How n comes, you have understood this. How n comes, you have understood this. So for example, 691.4. 691.4 into 10 to the power 2. This one, how can we write in log now? 691.4. 691.4. When we will go for logarithm, then we have to make it in standard form. Standard form means decimal should be after one digit. That means this decimal will move here. That means we have to write 6.914. 691.4, we have made it 6.914 into 10 to the power. How many digits move this side? 1, 2. 1, 2. So 10 square. Then only it will be okay. 691.4 is equal to 6.914 into 10 square. This one also I will show you the example. This one I will show you an example. This example only I will show you how it is possible. 691.4. If we multiply by 100 and divide by 100, it will be same. Meaning is same. Value will be same. Now 691.4 into 100. If we write, sorry, 691.4 by 100. This one we will do the calculation now. 691.4 by 100 we will do the calculation. How we will do this calculation? I will show you here. Look here. If it is 52 by 100, this one I will rub it, then I can write properly. You will pause the video and you will note it down, or you can hear everything. 52 by 100. What will you write? 0.52. If it is 5.2 by 100, then what will you write? 52 by 100, we have written 0.52. If it is 5.2 by 100, then what will you write? Then we will write, if you will do properly, then what we will do, we will multiply by first numerator and denominator by 10. Then 5.2 into 10 is 52. It is by 1000. 100 into 10 is 1000. So what you will get now? 0.052. 0.052. Okay. So 5.2 by 100. If we want to make it a decimal number, direct decimal number, you will get 0.052. Or for 5.2, if you divide by 100, look here. 5.2, let us divide by 100. 100. So here we will add 10, no problem, decimal is there. So here we will add 5, then 500. Decimal will go up as it is. So this place is blank, so this is 0. Then 2 comes down, 0, again 0, 2. 100 into 2 is 200. So 0.052. 0.052 we have got. So what I was explaining here, so 691.4 by 100, what we will get answer? 6.914 into 100. 2 zeros are there, so decimal will move 2 places. 2 places, 1, 2, then decimal. Because 2 zeros are there. If it is 3 zeros, 3 places will be moving. So this 100 will be as it is. So we can write 6.914 into 10 square. This is called standard form for logarithm. For logarithm, you have to learn this. This 691.4, whatever number, 5926.45. Okay. So we have to make it standard form. So decimal must come here. 5.92645. How many places, how many digits moved? 1, 2, 3. So into 10 to the power 3. This one I have explained you. By dividing also I have explained. So you understood, I think. This decimal has moved this side. How many places? 1, 2, 3. So into 10 to the power 3. So this is standard form. This is what here it is explained. Okay. Now this one, if we want to make it log, so here log 10 cube, log 10 cube. So what you will get? 3 log 10. 3 log 10 means 3. 3 log 10 means 3, because log 10 is 1. So 691.4 equals to 6.9 log 6.914 into 10 square. Square means log 10. 2 log 10, so 2 comes alone. Here 3 will come alone. Okay, this one I will show you if you have not understood. Okay, this one I will show you what is given in the book. That one I will show you what is given in the book. What is given in the book? Log 691.4. This one. Okay, log A, here log 691.4. Other part we have to get now. So how will you get? Let us write log standard form 6.914. Decimal moves 2 places. So into 10 square. Into 10 square. Again, log 691.4 is equal to log 6.914 plus log 10 square. Again, log 691.4 log 6.914 plus 2. 2 will come back, 2 log 10. Log 10 is 1, so 2 I have written. So one more line let us write. 691.4 is equal to 2 plus log 6.914. This is what here it is written. Okay. So 2 plus something. So this value we will find out. Now later, next page, next session, we will learn how to find out the value of log 6.914. Thus, the logarithm of a positive real number to the base 10 is always consist of two parts. The integral part is called characteristics, and the fractional part is called mantissa. Characteristic and mantissa. When the number a whose log is required is expressed as a equals to m into 10 to the power n, when n is an integer m equals to 1, then the mantissa will be 0 in log a. So this one I already explained. A is equal to m into 10 to the power n. When n is 0, then 10 to the power 0 will be 1. When n is 0, we will write like this now. So a is equal to m into 10 to the power 1. That is what here written. Then the mantissa will be 0. 0 in log a. Here log a you will be have only the characteristics. Only characteristic, because this is m into 1 is m only. So only characteristic will be there. So there is nothing to learn here. Okay. Now determination of characteristic. Here what is the characteristic? 2 is the characteristic. 2 is the characteristic. That already we have learned now. Integral part is integer, that is called characteristic. Other part is called mantissa. So here characteristic is 2. Why 2? Because 10 square was there. When we will get 3? When we will get 10 cube. When we will get minus 2? When we will get 10 to the power minus 2. So 10 to the power whatever that is related to characteristic. Log 691.4, its characteristic is 2 because there is 10 square. When we converted this number into standard form, then we have got here 10 square. So 2 we will get characteristic. Okay. So when we will get negative, this one also here explained. Here what we have got 10 to the power minus 3. Something into 10 to the power minus 3. So characteristic will be minus 3. So when we will get minus 3? When decimal 0.001. This one also I will explain here. Wait. Here only let me explain. Here you will look here 0.00562 log. This is not in standard form because decimal is after decimal 0 is there. So decimal should come here after 5. Here I have already told you about the standard form 691.4. This is not in standard form. We cannot find out the logarithm of this directly. So we will make it this way. Why? Because it is not in standard form. Decimal should come just after the number. So here decimal must move here. Okay, so log 5.62 into 10 to the power. How many places moved? 3 places. So minus 3. Here, how many places moved? 1, 2. 2 places moved. So 10 to the power 2. Moved towards left hand side. So power will be positive. Move towards right hand side. Power will be negative. How it is? Because already I explained 0.00562. 0.00562. If we want to get the decimal in this place, then we have to multiply by 1000. If we multiply by 1000, we have to divide by also 1000. When we multiply this one and this one, what we will get? We will get 562,000. 562,000. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Decimal here. So 0, 0, 0 cancel. Here what is there? 1000. So 5.62. 1000 we can write 10 cube. If it goes up, it will be 10 to the power minus 3. 5.6 to 10 to the minus 3. So shortly what you have to learn, you have to see direction of movement of decimal. If the decimal moves towards right hand side, then power will be negative. If decimal moved towards left hand side, then power will be positive. That is about characteristics. What we are learning? Characteristics. Okay. 7341.62. So this one how we will write? 7.34162. Here decimal was there, so decimal moved here. 1, 2, 3 places. 3 places, so 10 to the power 3. So what will be the characteristics? 3. Whatever the power of 10, that will be characteristics, because log 10 is 1. 3 log 10. Log 10 is 1. So 3 will be left as it is. Oh, sorry, alone. So 203. One by one I will show you. 203.197. So this one we will write 2.03197. So decimal move towards left hand side. How many places? 2 places. Into 10 to the power 2. So characteristic we will get 2. Here there is 2. 47.62. 47.62. This one we will at 4.762. How many places moved? Only 1 place. So into 10 to the power 1. So 1 is characteristic. 87. 87 means 87.0. Same thing. Only 87 or 87.0, same meaning. 87 means here decimal is not clear, so we can put it like this. So here also this one only 1 place. So 8.7 into 10 to the power 1. So here also characteristic is 1. 8.359. 8.359. This one you don't have to move because this is already in standard form. So just you can write 10 to the power 0. This is already in standard form because after 1 digit there is decimal. So we don't have to do anything here. So nothing means 10 to the power 0. So characteristic is 0 for this one. 0.518. 0.518. Now decimal will move here 1 place towards right hand side. So 5.18 into 10 to the power minus 1 towards right hand side. How many places? 1 places minus 1. So characteristics minus 1. 0.00529. 0.00529. This one. This decimal will move here after 5. 1, 2, 3 towards right hand side. So 5.29 into 10 to the power minus 3. So characteristics will be minus 3. So here decimal will move how many places? After 6. 1, 2, 3, 4. 10 to the power minus 4. So minus 4 is the character. So that is how we find characteristics. Sometimes characteristic we get positive number. Sometimes we get negative number. So here upper parts 3, 2, 1, 1. So this is positive all. Here 1, 2, 3, 4. This down part all negative. That's what we have understood. After decimal, if zeros are there, then we will get characteristic negative. If no zeros, then we will get positive characteristic. Example 1. So this is very simple. Log 32.17. We have to find out the characteristic. We have to find out the characteristic. So what we will write? Log 3.217. Log 3.217. So into 10 to the power. This decimal moved towards left hand side. How many places? 1 places. So 10 to the power 1. Or we can write log 3.217 plus log 10 to the power 1. 10 to the power 1 is 1 only. 10 only. So log 3.217. Log 10 how much? 1. 1. So we can write 1 plus log 3.217. What is the characteristic? 1. Here the characteristic is 1. Second example, log 0.00103. So this is not in standard form. So what we will do? This decimal will move here after 1. 1, 2, 3 towards right hand side. So what we will write? Log 1.03. Decimal will come after 1. This is called standard form. How many places? 3 places. So into 10 to the power minus 3. Multiplication is there, so we will add 1.03 plus log 10 to the power minus 3. Again log 1.03 minus 3 log 10. Log 10 is 1. So minus 3, or we can write minus 3 plus log 1.03. Why we have written? Because this is the place for characteristics. Second part is for mantissa. So first part always you have to keep a whole number, an integer. First part, that is why minus 3 is taken here, plus log 1.03, so taken in second part. So characteristic is minus 3. Characteristic is minus 3. Determination of mantissa. Now we have just till now we have learned about characteristics. 10 to the power minus 3, characteristic will be minus 3. 10 to the power minus 4, characteristic will be minus 4. 10 to the power 7, so characteristic will be 7. Now we are going to learn about mantissa. So for mantissa, that means second part. Second part will be always decimal. So for that, here some examples are there. So log 0.04963. So here we have to get the significant digit. Significant digit means excluding 0. Excluding 0, whatever numbers are there, they are called significant digit. Significant digits. Again, log 0.00082. Its significant digit is 82, only the number. And remember that significant digit should be always 4 digit. Always 4 digit. So here only 82 is there, so 2 more 0 we have to put by ourselves. Only 82 was there, but we have to make it 4 digits. Significant digits will be always 4 digit. And one more. Log 613.43. 613.43. Its significant digit will be 6134. Only 4 digits. So this significant digit, why we are learning? We will get later on. This significant digit we are learning to learn how to find out the log of any number from log table. Logarithm table is there. That logarithm table we cannot learn by heart. Some of the values, small values, we can learn by heart. But all the values, because 1 to 100 values are there, and different values are there, rows, columns are there, so that you cannot learn by heart. So we have to learn how to find out the logarithm with the help of log table. So that why we are taking 4 for significant digit we have to get 6134 significant digit. So there will be always 3 parts. First part will be always pair. One pair is first part, second part single number, third part also single digit. First, let me tell you again, let me repeat. This first will be always with a pair. Second will be with a single digit. Third will be always with a single digit. Then only we will get the value of any log if we get a significant digit. Significant digit is of 4 digits. First will be with one pair. Second is only single, and third is also single. This one. Now, here it is one example. Suppose we are to find out log 43.61. 43.61. Log 43.61. Before we go to find out the value of log 43.61, we will make it first standard form. 4.361 into 10 to the power 1. Because only one place moved. 10 to the power 1. So, mantissa is, characteristic is 1. Log 4.361. 10 to the power 1. So I have written directly 1 because already I explained. Here also written 1 plus mantissa. This part is mantissa. 1 is characteristic. We have got characteristic already. So 1 plus. This 4, this forget about decimal now. This just for time being, forget about this decimal. 4361. 4361. 4361. We have to make it 3 parts. 1 part, second part and third part. 3 parts. First part will be 1 pair. Second part 1 single digit. Third 1 single digit. Now we will find out the value of log 4361. Just forget about decimal. 4361 with the help of log table. Now we will go to log table. How to measure, how to find out log value of log anything with the help of log table. This is the log table. This one you cannot learn by heart. This one you cannot learn by heart. This is logarithm table. Here what is there? You look here. Here 10 from starting from 10, 11, 12 till 100 it is there. 10, 0, 10, 1, 10, 2 like this. 20, 0, 22, 23 like this. It will go on till 9. And mean difference is there from 1 to 9. So what was there? Log, let me see from the book, log 4361. 4361. As I have told you, first part, second part, third part. 4361. Now we will see where is 43. First we will see where is 43. So 43 is here. So this 43 let us mark till last. I have marked. So this part is called mean difference. Okay. Okay. This is 43. This is 43. I hope it is visible for to all of you. 43. There is, so 43 I have marked and I have marked a line till then. That row I have marked. Next 6 is there. So I will see the column of 6. This is 6. So from here I am drawing a line. Here I have got a number. This is the line for 43. Next 6 is there. So we will see the column of 6. So touching here 6395. So we get 6395. So 6 finished. Now 1. This will be from mean difference. So 1. This is 1. So here it is 1 only. Value is 1. So we will add here 1. That means 0, 0, 0, 1. 6, 9, 3, 6. Here decimal will be there. Okay. I hope you understand. Let me explain again. We have to find out the log of 40 log of 4.361. 4.361. This one we have to find out. Characteristic we have got 1 already. So mantissa we have to find out. Mantissa we have to find out with the help of logarithm table. This is the table. So we have to get always 4 digits, significant digit. Significant digit means 4 digits. So without decimal 4361. So I have made it 3 parts. First part is of a pair. Second part single digit. Third part single digit. So why pair? Because here you will get a pair only. 10 to 99. 10 to 99 all 2 digits number. So first one we have taken, that is why pair. 43. Next 6. So 6 was there. So 6. This is 43 line. This is the line of 43. This is the line of 6. So touching here, no? 695. So I have written 695. Then after 6, 1 is there. So we will go to mean difference. Third number is for mean difference. Second number is for this part. Main logarithm table. Third number is for mean difference. So this one line, this is 1. So one line touching here, 1 only. So 1 I have added 0.6396. 0.6396. So we can write 1.6396. I hope. Yes. 1.6396. Here, there I think 5 digits, so we don't have to worry for that. 6396. Here they have got 1.63959. 63959. After 5, 9 is just so we can make it 6. That is no problem. So 1.6396. So I am making it short to make you understand easily. You don't have to worry about this 5 digit. After decimal, better you keep always 4 digits. Nobody will cut. It is always true. You don't have to worry about that. So log 43.61, we have got 1.6396. 1.6396. I will show you one more example. One more example I will show, then you will understand properly. This one, please pause the video and you will learn it properly. Suppose log of 2857. Decimal is here. 285.7. So what you will add? Log 2.857 into 10 to the power 2. Decimal move 2 places. So surely we will get characteristic 2 because 10 to the power 2. I hope you understand that. Now log 2.857. Now we will have to find out the value of log 2.85. What is the significant digit? 4 digits. 2857. No decimal. Don't have to worry about decimal. So 28, first one should be always pair. Second one digit, single digit. Third one also single. Now we will go to log table. First 28 is there. Where is 28? This is 28. If it is not visible, I will make it little bigger. No. Okay. 28. This is 28. This is 28 line. This row is for 28. Okay. You don't have to draw the line. I have just here to make you understand. I am drawing the line. You don't have to draw the line because you will get this one. You will get in from. You will download this log table from Google. From Google, you can download this log table. This log table is not in your book. So I have not found, because it is written here, back side there is log table, but here log table is not available in this book. They should give, but they have not given. Anyway, so you will download the log table from Google. Now 28, then 5. So 0, 1, 2, 3, 4, 5. This is the line of 5. So this is the number. What is the number? 4548. 4548. 28, 5. 5 we have got. Then 7. Okay. Okay, 28, 5, 4, 5, 4, 8, 4, 5, 4, 8. This one is 5, no? This one is 5. So 5. This is the column of 5. This is the row of 28. Then 7 is there. So 7. There is 11. So we will add 11 here. 0, 0. This way. 8 plus 1, 9. 4 plus 1, 5. 5. 4. So here what you will add? 2 plus point decimal 4559. So 2.4559. This is the answer. What is the value of log 285.7? 2.4559 with the help of log table. I will show you one more example, then I will proceed for next. Please pause the video and learn it properly and note it down. log, suppose 2268, 226.8. So how will I write log 2.268 into 10 to the power 2? Decimal move 2 places. So 2 plus log 2.268. So significant digit 2268. So first one should be pair, second one is single number, single digit, third one is single. So we will go to 22 now. This is 22. This is the column of, sorry, row of 22. Then next 6. So we will go to 6. 22, 6 is touching here, 3, 5, 4, 1. So 3, 5, 4, 1. Then 22, 6, 8. So we will go to 8. 15 is there. There is 15 in the line of 22. So here we will add 15. 0, 0 you can write 6, 5, 5, 3. So 2 plus decimal 3, 5, 5, 6. So answer is 2.3556. So this is how we use log table. We have to know the use of log table. This log table will be given in exam if it is big sums, or the value, some of the values of log table from the log table, it will be given in the question itself. You don't have to learn by heart this log table. This is not necessary. So significant digits you have understood. After that, this one here, just making you understood that log we get 30, what is there? Yes, log 0.2013. 0.201, this one I will show you in that page. So this one, how to make it standard form? 2.013. This one is move one place towards right hand side. So into 10 to the power minus 1. So surely minus 1 is the characteristics. Minus 1 will be the characteristics. Plus log 2.013. So significant digit 2013. 2013 significant digit, 4 digits. So 21 3. So let us go to table. Twenty-one 3. No, 21 3. 21 3. Now we will go to 20 now. This is the line of 20. 21. So this is 1. 3032. 3032. 21 finished. Now 3. Mean difference 3. Mean difference 3. This is 6. So here 6. So 3038. 3038. Minus 1 plus 0.3038. Here you may get something 30384. They are using a bigger log table, so you don't have to worry for that. They are writing 30320. They are using a log table in which 5 digits are there. So you use this log table in which 4 digits are there. So it will be almost same. 30384. 30384. Look here, 3.30384 and 0.3038 almost same. Almost same. So we don't have to worry for that. Now we have got negative number in characteristics. This one already you have understood. And then we have to write when we get characteristic negative number. When we get characteristic negative number, then we use bar, 1 bar. When we get negative, then only 1 bar 0.3038. This is what written here. This one we can make it minus 1 plus 0.3038. This one you can calculate also. You can calculate normally. 1 bar 0.30384 can also be taken as minus 1 plus 0.30384. Because from 1 3038, we can subtract now. 2696.6962. 0.6962 negative, because 1 is bigger. 1 is greater than 0.3038. Before greater number there is minus sign. So minus 0.69. 69616, 6962, same meaning. 69616, 6962, same meaning. Meaning is same. You don't have to worry for that. Okay. So till this much, I hope you understood everything about log table. You have to be very serious about log table. And log table you can download from Google very easily, and then you can understand properly. Please learn. Please have a comment in the comment box. If there is any problem about using of log table, I will explain again. So till then, have a good day.